All right, so the next lesson in this unit is on something called arithmetic growth. All right, so so let's just take a look here at the first example. We want to find the next three terms in the following sequence. All right, so a sequence, so basically there's a pattern to these numbers, and we just want to complete the pattern or the sequence. All right, so for instance here, if I go 2 to 6, what's a logical number that could go there? So you might think, oh, 18, right? Then 54, and 162. All right, because to get from 2 to 6, I multiply by 3. 6 to 18, multiply by 3, and so on. So basically, you're just tripling numbers in the pattern. Okay, so that's one possibility. Another possibility is if I go to 6. You think about it, another number, the next number here could possibly be 10, 14, and then 18. All right, so to go from one number to the next, instead of multiplying by 3, right, we can add 4 to each one. All right, so these are two different sequences, or two different types of sequences. The first one here is called geometric. So this is a geometric sequence. And you actually will not learn this or the intricacies about these patterns until pre-calc 12. All right. What we're going to be focusing on here is on something called an arithmetic sequence. All right. For arithmetic growth. All right. So for our unit here, or for this lesson, we're going to take a look at an arithmetic sequences. All right. So arithmetic, basically, we add or subtract. Right? Because adding and subtracting are kind of the same thing. Right? To subtract, basically, you're adding a negative number. So anyways, adding or subtracting involves arithmetic sequences, whereas geometric sequences is when you multiply or divide. Okay, so again, you're not concerned with geometric sequences at all. This lesson, the next lesson, we're just looking at arithmetic sequences where we add a number to get to the next. All right. Now the number itself has a special name. All right, so you're adding the same number each time. And this is called the common difference. So, and it's generally the variable d. So if you see the letter d in the textbook or in this lesson, it's referring to the common difference. All right, so what number do you add or subtract? Sorry, what number do you add? Yes, to get to the next one. So sometimes you'll add a positive number, sometimes you'll add a negative number, but it's always adding. It's called the common difference. Now, in terms of like labeling, this is the first term, 2. Now, in terms of notation, we're actually going to call it t with a subscript 1. So this means it's the first term. So that logically means that 6 here would be t2, 10 is t3, 14 is t4, and 18 is t5. Okay, so the fifth term in the sequence is 18. So t5 is equal to 18 in this example. All right. So I just wanted to show some kind of the notation behind it. So complete the arithmetic sequence. We have a blank. So we've got to figure out what numbers would go in the blanks. If the 6 is the second one, the -6 is the fifth one. All right. So how would we do this? All right, so what we want to realize is that to get from one number to the next, we're adding common difference. So right now we don't know what the common difference is, so I'm just going to call it D. All right, so to get from 6 to the next term, right, we basically need to add the common difference to get to here. And then to the next one, we're going to add the same number, the common difference. That'll get us here. And we add the common difference again to get to -6. All right, we can actually develop an equation just by looking at what we just wrote out here. All right, so if I start at 6 and add d, I get here, add d again, I get there, add d again, I get to -6. All right, so if I wanted to translate that into an equation, if I start with 6, add the common difference, add the common difference again, add the common difference again, it will take me to -6. All right, so visually, hopefully you guys see that. Now, to solve this, I can collect my like terms. So this, in other words, 6 plus 3d, or 3 of the common differences. If I take 6 and add the 3 common differences, it's going to take me to, or it's got to equal -6. So if I solve this equation, I'm going to figure out what the common difference is, right? All right, so that's what we're going to do here. Let's just solve this equation. So I'm going to move the 6 over to the other side. Now, be careful, right? This 6 and this -6 do not cancel. When the 6 gets moved over to this side, it becomes -6. So as a result, I have 3d here. But over on this side, I have -6 minus 6. Again, that's not 0, it's -12. All right, so now if I want to solve for d, I'm going to divide both sides by 3. That gives us the common difference of -12 divided by 3, which is -4. All right, so what that means is to get from one number to the next, I'm going to add -4, or in other words, subtract 4. All right, so let's see if this works out. We have blank 6. So the next one here, from there, this says the common difference is -4. So 6 plus -4, in other words, 6 minus 4 is 2. Now, do the same thing here. 2 minus 4 takes us to -2. -2 minus 4 is -6. All right, so you can see here 6, 2, -2, -6. That will follow this pattern. And if I want to go one step further, -6 plus -4 or -4 is going to take -10. All right. Sorry, so I didn't write that out. I was just kind of blabbing away. But anyways, just visually, right, if you see it, I'm just subtracting 4 each time to get these numbers. Now, if I want to go in the other direction, obviously I'm not going to subtract 4. I'm going to do the opposite, add 4. 6 plus 4 is 10, right, which confirms it, because if I went in this direction, 10 to 6, I'm going to have to subtract 4. All right, so yes, to solve this kind of puzzle, basically you need to solve for the common difference and then just apply it to get the blank numbers. Cool, guys. So yeah, so that's it. Short one today. So hopefully that makes sense. Cheers.